Hey guys, this is Archimedes Tutor, and in this video we're going to be doing word problems with square roots and exponents. In the previous two lessons we learned what square roots and exponents are, how to write them, and even how to estimate square roots. In this lesson we're going to be applying all that knowledge in these word problems. So get ready. First up we have number 1. A square-shaped house covers an area of 2,500 square feet. What is the length of one of the sides? So let me just draw a diagram. There we go. I have a square here, and suppose this represents the house, and this represents an area of 2,500 square meters. So we know that in a square all four sides are equal. So let me just draw the symbol for equal, these four lines. And we also know that the area of a square is composed of length times width, or in this case, since both sides are equal, we can call this side times side, and to simplify it, s squared. So there we go. We know that we have an exponent in this equation. We know that the area of the square, or the area of the house, is 2,500 square meters. So, and the formula of the area of a square is s squared, as we just deducted. 2,500 square meters equals s to the power of 2, or s squared. So now to find the length of one side, or s, I can simply square root both sides of the equation to get rid of the exponent of 2. So I'm going to do that. The exponent of 2 is gone, and we are left with s equals the square root of 2,500 is a pretty big number, so I'll use my calculator. Square root symbol, 2,500, and that gets us 50. So I'm going to write side equals 50 meters, and a therefore statement. Therefore, one side is 50 meters. Let's move on to our next question. Okay, question number 2. A bacterium cell doubles itself every hour. How many bacterial cells are there if one cell were to be multiplied for 5 hours? 10 hours? Okay, so this time I have a table drawn out, where the left side of the table represents the number of hours and the right side represents the number of cells. So let's begin. At 0 hours, we are to assume that there is only one cell. At 1 hour, 1 doubles or multiplies itself by 2. So we'll write 2. At 2 hours, it will double again. So 2 times 2 is 4. 3 hours, double again. 4 times 2 is 8. At 4 hours, 8 times 2 is 16. And we'll just extend it a little bit. At 5 hours, 16 times 2 will be 32. So at 5 hours, we know that there will be 32 bacteria cells. Now instead of extending our table more to find the cells when there's 10 hours, how about we just make a small expression? Okay, so we know that doubling involves the number 2. So our base of this exponent, or the power, will be 2. And for each hour represents its exponent. So for example, 2 to the power of 0 will be 1, and you can check that on your calculator. 2 to the power of 1 will be 2. 2 to the power of 2 will be 4. And so on. So suppose my general expression is 2 to the power of h, where h represents the number of hours. Now if I want to find how many bacteria cells there are at 10 hours, all I need to do is substitute 10 hours for h. So 2 to the power of 10, which is equal to 2 to the power of 10, gives us 1024 bacteria cells. Well, so therefore at 10 hours there are 1024 bacteria cells. You can even check your answer by extending this table, but you might want to know how I derived 2 to the power of h. Well, let's see. Since it said multiplied, we knew that this graph was exponential, meaning there's no constant pattern, the value keeps on increasing. So I noticed that the word double means it involves an exponent. So you might want to keep that in mind, that when you see words like double, triple, quadruple, it means to have an exponent. So double meaning 2, I wrote 2 as the base of the exponent, which is the number being multiplied. And the exponent was something that varies. So for example, the number of hours, which varies, I wrote that I let h represent the number of hours, and once we got that, I can just plug any value into this expression and I will get my answer. Now for our third word problem, I have a square drawn beforehand. Okay. Number 3, Mr. Flanders wants fencing done for a square garden. The area of the garden is 74 square meters. What is the amount of fencing required for the garden in meters? Okay, so basically, this is a square garden, suppose. It covers an area of, 74 square meters. And the fencing, meaning the perimeter, is what we have to find. Right off the bat, you should be able to notice that 74 is not a perfect square number, which means that if you were to square root it, you will not get an integer as a result. So we have to find its precise value. So in the previous lesson, we learned how to estimate square roots, so we're going to do that once more. I'll be using the number line method to estimate. I know that the square root of 74 meters is somewhere between 8 meters and 9 meters. So I'm going to write 8 meters over here and 9 meters over here, and the respective square roots above. 8 meters squared will be 64 meters squared, 64 square meters, and 9 meters squared will be 81 square meters. Somewhere over here we have 8.5 meters. Upon observing, we can point out that the square root of 74 meters squared is 7 steps away from the square root of 81 meters squared, and approximately 10 steps away from the square root of 64 meters squared. So it will be closer to 9 meters. 10 away, so somewhere over here, and 7 away. It will probably be a little over the half line. Maybe I'm guessing over here. And this is purely based on instinct. Probably about more closer here. And I'll say not 8.7 meters, that would be a little too far, considering that the distance from 64 and 81 meters squared is 17 steps. And it's only 3 steps away from the half line. So I'll say maybe, 8.6 meters will do. 8.7 meters will be a little too far. So let me just check my answer. The square root of 74 meters squared. Yep, 8.6. And it's okay to get it wrong. You shouldn't be off by too much though. So it's 8.6 meters approx. Now that we know that one side length is equal to 8.6 meters, we need to find the perimeter of the garden. So to do that, we'll just add up 8.6 meters. You can multiply by 4 since all sides are equal. And that will give us a perimeter of approximately 34.4 meters. So Mr. Flanders will need 34.4 meters of fencing. So I hope you got some good practice out of these word problems. Thanks for watching. I hope you found this video helpful, and if you did, please be sure to click the subscribe button. My next lesson will be unit review of everything we covered so far in grade 8. And if you want more word problems or practice like these, you can always visit my website www.archimedestutor.com. Until then, stay tuned to Archimedes Tutor.